When you ready, Pak.
Okay, let's begin. So, good afternoon, ladies and gentlemen. Welcome to the fourth session of the presentation in Intelligent System class. Our group are going to talk about the application of computer vision in real life. Before we proceed into the presentation, we would like to introduce ourselves. So, from that side, there is Guntur. This is Titan, which will be our main speaker. Chris, myself, William Praharja, Axelina, and our supreme leader, Dava Japri. So, before we begin our presentations, let us hail our supreme leader, Dava Japri, with his inspiring motto, illegal is legal, as long as you don't get caught. Kepada Muhammad Dava Japri, hormat, gerak.
You're fired.
Okay.
So the session will be continued mainly by Titan Gusto.
Can you please use the mic?
Okay, good afternoon everyone. So yeah, for the rest of this presentation, I will be the main speaker. So now, what we aim to achieve by the end of this presentation is that you as the audience are able to recognize and understand the applications of computer vision in real life. So yeah, this is a quick definition of what computer vision is. Computer vision is essentially the ability for a computer to process and analyze image data from real life. And essentially it's again, it just turns like visual image into data that the computer can actually read and process. Okay. So these are just some of the problems that computer vision can These are just some of the industries in which like computer vision can be applied to solve problems. We have finance, manufacturing, healthcare, e-commerce, automotives, and etc. But for this presentation, we'll be concentrating on finance, manufacturing, and the automotive industry. So manufacturing. Manufacturing, for those of you who might not know, manufacturing refers to like, well, you know, making things in factories, like constructing small objects, making bottles, making cars, that kind of stuff. Anything that involves an assembly line is essentially part of manufacturing. Next. So yeah. So why would you use computer vision in the manufacturing process? Well, as you can see here, it's all about quality control. You use computer vision to make sure that there are no flaws, there are no imperfections in the products that you produce during the manufacturing process. Next. So, we will be talking about those three. I will be talking about those three industries in references to various case studies. So the case study we're using for manufacturing is by Shelton Vision. Shelton Vision are machine vision specialists who, well, use their skills to like solve industry problems regarding like manufacturing. Next. Okay, so here are Shelton Vision's 4 steps to perfect their manufacturing process in terms of profit. So step one, they basically they have an unrivaled inspection accuracy of real-time defect classification and grading. This is basically to make sure that everything is again like to inspect that all the produce in an assembly line is up to standards based off quality control parameters set by an actual human. Step two would be a commercial overview of the defect mapping. Like the final commercial decisions regarding about what the product should look like are made by a QC technician. QC technicians here are not machines; they are actual humans that will set parameters for the software, for the computer vision to adhere to. And step 3 here, this is where it gets a lot more practical, because this part, the yield optimization multiple cut plan creation in virtual form, this refers to the the AI's machine vision's capability to actually like set how say for example you're in a steel mill. If you want a sheet of steel in a certain size on a certain thickness, this is the part that that basically handles that. It optimizes how much time is needed to and like how much it would cost to actually make that certain size in certain time. Basically, step 4 is also just basically automating the whole process. So after a person starts just like setting parameters for the entire process, then just leaves it to go, and there you have it. That's the 4-step process for Shelton Vision, and like how it would solve problems in the manufacturing industry. So our next industry is finance. So here we'll be referring to China's recent China's recent implementation of facial recognition software for various aspects of life. So in this month in China, the Chinese government passed a new motion so that like for pretty much any purchase that like a Chinese citizen would make, they have to use a facial recognition software to verify their own identity. Like this can apply to many things, but like for the cases here, we're talking about if you want to sign up for internet services or you want to get a new phone, you have to like verify your identity through facial recognition. So yeah, basically now, pretty much every person who uses the internet in China is now required to use facial identification again. Basically, just reiterating my previous point. Next. So yeah, this is just like another like real world example of of how the government aims to like monitor citizens. You might think this policy created by China also raises some issues in terms of privacy and such, but at the same time, the Chinese citizens seem to believe that as long as like they are okay with having their privacy taken away from them to an extent, as long as it increases their safety in life. And this also basically makes identity theft or just theft in general a lot harder to fake. Next. Yeah, again. So this new rule is basically part of the Chinese government's plan to keep tabs of and like track their citizens and monitor their behaviors. So yeah, next we're going to be talking about the automotive industry. So the most common example for machine vision in the automotive industry is, well, self-driving cars. Self-driving cars as of right now aren't too widespread thing, but we have what is called in a lot of cars nowadays stuff like cruise control, auto parking, lane detection, and that kind of thing. All of those are real life applications of machine vision. Okay, next. So yeah, again. We have lane line detection. That's so that a car is able to like, if you put a car in cruise control and like you don't have to press the gas, you don't have to steer it, it automatically stays within the lines of a road, so it doesn't switch lanes. You can actually, specifically, I think the newer Tesla models can actually switch lanes if you make them switch lanes. Oh yeah, and also you can actually, using collision detection and basically checking what's in front of the car, they can look at obstacles and road signs and such. And yeah, steering angle commutation is another extension of lane line detection because it makes sure that the car stays in the lane even if the lane is curved. Okay, next. Okay, yeah, so yeah, when we talk about self-driving cars, like probably the most famous person who is currently making self-driving cars is Elon Musk and his company Tesla. Yeah. So yeah, this is a visual representation of of an autopilot car, a autopilot, a self-driving car. So yeah, as you can see, basically the car would just stay in the lane. It'll maintain a constant speed based on what's in front of it, and because of that, it would also be able to stop because like it processes the information that is shown in front of it, sees that if a car is too close to it, it will start to decelerate. Yeah. Next. Okay, so the conclusion that we made from this is that machine vision is able to solve various problems in our society, and also having machine vision also allows people to realize their ideas and create solutions for those, create solutions and find different ways to solve problems. And these are our references. Thank you very much. Any questions?
Questions, fine. Come on. Who wants to be the first? Okay.
Not me.
Come deh. Nanya biayanya 50.000.
First group. Cindy,
Yes.
ask questions?
We reserve the right to refuse your questions.
Yeah.
No, you cannot refuse the question.
Yes.
You cannot ask anything.
Yes, it's your friend.
No.
Sakit.
Bukan sakit nanti.
Supreme leader kita.
Supreme leader kita butuh pendampingnya.
Apa sih? Supreme leader.
Sebelum dia sedang usaha. Tindernya sedang aktif.
Banyak on Tinder ya. Why? Back to the real question.
Hah?
Tinder berapa akal?
Ada 5.
Astagfirullah.
Tapi akun yang aktif itu kuda jantan Jakarta.
Aduh.
Udah jantan.
Kuda jantan asli Jakarta. Right?
So yeah, any actual questions? Gak ada miss, gak
Very
apa-apa.
clear, miss.
Okay, miss.
I mean, it's pretty much the practice in the computer physics is quite clear, yeah. Because a lot of problem that we try to solve is based on AI now. You can see that what kind of thing you would like to implement. For example, the chess is not actually using computer vision, but you can try to use computer vision to solve it. I mean, like, because it's based on the deterministic problem. If you would like to know more about the thing that you can solve in your work, you can try to think more about what kind of example. Is it going to use a vision as the mind problem? For example, you are trying to look over the as the vision. Like for example, you are trying to look over the horse race. You can try to use the computer vision and try to check which horse is running better, which horse is performing better. Just one of the examples for implementing this kind of thing. Even you can try to prevent the people that try to gamble by cheating. Implement the computer vision. Why my example is gambling? Well, a lot of things is involve money, so yeah, it's more interesting in that part.
It's not cheating if you don't get sober.
Yeah,
just like
illegal
our
is legal.
If you don't,
As long as you don't get caught.
If you get caught, then
Kayaknya
kita harus ganti lagi slide-nya ke Supreme Leader.
Grupnya Friendly.
Ivan.
Ivan deh.
Pan nanya Pan.
Yang jahat, lu tiap hari jahat.
Kalau yang jahat yang jauh udah apa?
Yang jahat,
Yang jauh.
kenapa jelek? Ya, ini jelek deh asalnya.
Dari samanya itu.
Tadinya belum nanya soalnya.
In implementation for computer vision, what is it the only solution for self-driving car?
For what? Self-driving car.
Ya.
And can we use only self-driving computer vision for self-driving cars, or it's better the other way?
Can you elaborate more?
Wait, what do you mean the other way?
Can you please
Can you use
elaborate?
self-driving cars for computer vision gitu
No,
maksudnya?
I mean nowadays like you mentioned is Elon Musk using computer vision to switch lanes or something like that. Right?
Mhm.
So is it the only solution?
Okay.
If it is not, is the second solution better?
What's the second solution?
What is
Jawaban pertama kita,
Oh.
like the other
Dia
solution.
nanya kita.
Okay.
Ada
Oh,
solusi
you mean
lainnya.
if there are any other solutions?
Yeah,
basically.
if there are any
If there
other
is a
solution.
solution, is
Or and is that would those solutions be better? Basically. Okay.
Let me discuss it for a while.
It's easy.
Supreme Leader. I fire you later.
jadi gaplok ya?
What you try to data, big data, so they can know each other without knowing the data.
Mem don't ask.
Let's say I can do it. It's actually my computer is broken, but I can use it
I'm supreme leader lah.
Oke. Okay, so after a bit of discussion, we believe that machine vision is probably the most realistic and the most efficient and easiest to implement solution in regards to self-driving cars. For now, maybe in some time in the future you can use something that like what we have decided to call peer-to-peer driving. So basically you could maybe say like cars would send information to each other regarding their positions. So it would be basically cars would be communicating each other to where they are so that you don't hit each other. That could maybe be something that could be done in later on. But as of right now, computer vision is probably the most realistic way to solve this problem.
Because you would like to care about the individual person who drives the car. That's why you're thinking about how do you make the car safe with the individual person. But later on, with the development of technology, of course, you can start like a grid computing. So basically, you can see one of them, like for example, they have a broken camera, and their computer vision is not able to append the data to the server. They can use the reference from other cars that run beside them to know which better for this car to be able to get in line. That kind of thing might be possible in the future. The idea is coming from our supreme leader, so anyone that tries to steal, you need to deal with him.
Actually, those ideas already.
Not mine lah.
No, our supreme leader is to copyright everything. Every Habuga is made by him.
Yeah, for you. Ideas are there.
Yeah. So, do you have any suggestion or additional thoughts with that?
Yes,
Any
don't
other
say like it's
questions?
from your supreme leader, because
You do not define the supreme leader.
You do not define.
Okay, any more questions?
He's supreme
One
leader.
more question, please.
If supreme leader say the color is red, if the color is white,
Felix.
say it's red.
Felix mau nanya, do you have any question?
Tanya
Toilet
Google.
sebelah mana? Tanya security sana.
Bukannya lu tahu Google aja coba sana.
Acang.
Kan dia ada kaca.
Ah iya.
Benang merah, benang merah, benang merah.
Okay.
Bukan ikannya 7.
More questions? More questions?
Oh, lama.
I mean, in the machine vision scope, do you think machines are smarter than humans when it comes to, finding solution to get out from an emergency? Example like self-driving car. If there should be a collide between two cars, do you think machine vision is the best solution to get away from that situation, or human?
Do you mean the smarter or by definition of the moral? Because this is the moral debate for the philosophical way. You need to define that if the car is going to hit somebody, it's going to sacrifice the guy who is driving inside of it, or the guy is keep chasing around in case that he might die if he stops, right? That's the kind of...
When we say lane detection, you are trying not to get into another lane or get to another lane car. So when there should be accident, obviously it's collide. The car is trying to, save itself, not the person.
Okay.
That's how it works. So that you don't collide with object in front, so there should be another exit.
Oh yeah. So basically, you're asking whether or not like the car would be able to like move lanes if there was an accident in front of it. Yes.
Yeah.
Okay. As far as I know, yeah, at least with Tesla cars, that's already been implemented. So like if there's something happening in front of the car, even like it will be able to switch lanes or at the very least stop. At the very least stop. There's like something that like that is obstructing it. At the very least, the car will be able to stop on its own.
And besides, if it's driven by human driver, you have to include how the driver feels first, because in an accident, our actions can sometimes we have a panic reaction, and that's also include our decision in whether or not we can handle the accident. That's from my experience.
Yeah, maybe for like human, when you are on a lane and you want to collide with another object, but maybe on your left side it's kind of like empty space. Your option will be, okay, let me just go through this. It doesn't matter. I just don't want to collide.
Okay.
But how do you think the machine vision will, handle this situation? Is it just going to halt at that very spot to follow human step, like, okay, let me just leave the lane, go left?
Actually, the question is more relying to should the machine sacrifice the guy in the driving steer, or is going to like save him, right? If there is something like, how do you? I'm confused with the question.
Okay. Basically, as far as I know, specifically with Tesla, the newer cars should be able to actually switch lanes if there's an obstruction in front of them. That's with Tesla specifically. Whether or not that's like the industry standard at this point, we don't know. But like as far as I know, with Tesla cars are already able to do that. So they will be able to mimic the human reaction to such an event. So that there's something in front, move to the other lane if it's possible to move to the other lane.
We need to think machine as the cold hard truth number. It's not human. So yeah, if you say that the machine able to panic is going to be very weird. So it's going to be take more logical reason. It's going to like, how do you say this? Avoid the obstacle no matter what. So the human in your position, we might collide it. We might collide with another obstacle, right? For example, there's car in front of you. There's stop suddenly.
Chris, jawab.
You want to add something?
Is that answer like sufficient for you, or do you like? Okay.
Question one?
It's because you kinda know the question.
Kenapa
It's your
saya masih
question,
single?
Okay.
Kenapa super
No
leader?
more questions?
Super leader kita mesti
Okay,
single.
thank you very
Karena
much
kita,
for.
karena dia terlalu
Kita di-upload kan?
Nanti di-upload,
Ke
please.
YouTube kan?
Enggak.
Videonya belum.